So when you are dealing with vertex form, the most convenient graphical feature that you can find from the equation is the vertex. Now let's see how we might be able to run that process in reverse. If you know what the vertex is, can you construct the equation? The answer is yes. And take, for example, this scenario. This is a very famous problem from physics. You have an object which you have launched into the air. So let's just get a little sketch going of this situation on the side. Here's the amount of time that's passed, and here's the height of the object. It's launched from some initial height, not necessarily from ground level. Maybe you're launching it from a height of 5 feet, maybe you're throwing it, or maybe you're on a balcony, or you're launching it from a catapult. So you launch it upward, and it rises up for a while, but eventually gravity takes hold and begins to bring that object back down to the ground. And this parabolic shape is formed of the object's height as a relationship with time that's passed. So the physicists have done some calculations and some observations, and they found that yes, the height of the object can be thought of as a quadratic function of the amount of time that's passed. But not only that, the physicists have worked hard and they found out exactly what the A value should be. The A value should be negative 9.8. Perhaps some of you recognize this number. Now, we've also know that for this particular object, the maximum height reached by the object is 30 meters. And the amount of time that it took to reach this height was 2 seconds. Okay, now someone says the word maximum to you, that keyword maximum, and what mathematical term comes to mind? Whenever somebody says maximum or someone says minimum, the first word that comes to mind in terms of mathematical terminology is vertex, which is the highest or lowest point. So I'm going to decorate this graph with some of the data that I know. The height at maximum, the height is 30. So I'm going to write 30 on the height vertical axis here. And this maximum height was reached after 2 seconds. It took 2 seconds in terms of time to reach this maximum height. So I'm going to mark that on the horizontal time axis, the x-axis. So here's the question. Based on this data, can we find an equation that expresses the relationship between x and y? Now, since this relationship is quadratic, we have a couple of different options. We could try and write this quadratic equation in standard form. We could try and write this quadratic equation in factored form, or we could try and write this quadratic equation in vertex form. And I think because we have been given information about the vertex of this quadratic, I'm going to go ahead and try and create this quadratic equation in vertex form. So I'm going to try and fill in a x minus xv squared plus yv with the appropriate numbers. Okay, now in the paragraph, they told me precisely what a should be. A is supposed to be negative 9.8. So now, what I would like you to decide, based on the fact that a is 9.8, and based on all the other data in this problem, first of all, what is the value of xv, x of the vertex? What is the value of yv, y of the vertex? And then try and fill in the blanks in vertex form. Okay, now that you've had a chance to try it, let's do it together. xv, the x of the vertex, that's the amount of time that it took to reach the maximum height. Y of the vertex, that's the amount of time, or I should say that's the maximum height that was actually reached. So if I fill in these numbers into their appropriate positions, I'll get the following relationship between x and y. Y is equal to negative 9.8 x minus 2 squared plus 30. And once you have this relationship, you really have the power to answer pretty much any other question that could possibly be asked about this scenario. I could say, what was the height initially when no time has passed? If I say initial height, no time has passed, you could, for example, plug 0 in for x here to capture the fact that no time has passed. I could ask you when the object falls to the ground. When, in other words, the object's height is 0. And then you could go in, replace y with 0, and solve that equation. I could ask, when was the object's height 15? You could go in and replace y with 15 and solve that. Once you have the equation set up, you can answer all kinds of problems.